Welcome to our new unit, kinetic and, well, it's an energy unit, but we're going to talk about kinetic and potential energy today, which is pretty easy because you did it in Science 10, and it's going to be the same stuff. So we're also going to add on some new physics skills in this lesson as well. So, got some questions, got some things for you to think about. So, draw energy on your whiteboard. Obviously, you don't have a whiteboard, but think about in your head what energy would look like, and think about to yourself, what is energy? Because it's kind of a weird idea. It's kind of a weird abstract thing, but people seem like, okay, energy, I know what that is. It's pretty straightforward. So just think about that for a sec. So I'll give you my definition on what energy is. And what energy is, it's just a type of bookkeeping that physicists do, right? It's very abstract. It's not something you can see, or it's not something you can see or directly, or I think it's supposed to say or touch directly. And when we analyze energy, we want to analyze it being converted from one form to another, right? We want to keep track of this thing as it's being converted from light energy, chemical energy, kinetic energy, gravitational potential energy, right? We analyze it as it gets converted from one form to another. So something about energy that's nice is it's scalar, so direction doesn't matter, so you never need to answer with direction when talking about energy. And it comes in lots of different forms. So these are the ones that we focus on in physics. There are other forms of energy. So kinetic energy, gravitational potential energy, and work are what we're going to focus on in Physics 20. And then in Physics 30, we talk about electrical potential energy, photon energy, mass energy, which is a pretty cool idea. So these are all just different forms of energy, and it can be converted from any of these forms to any other forms of energy. So kinetic energy you're familiar with. It's got the formula EK equals 1/2 mv squared, right? And you did this in Science 10, where EK is your kinetic energy, mass is your speed, m is your mass in kilograms, and v is your speed in meters per second. So with energy, because we want to answer in the joule, you have to use kilograms and meters per second. You can't use kilometers per hour at all. And on your data booklet, all of these are found under work, energy, and power, all on this bottom section here. So kinetic energy is right there on your data book. So determine the kinetic energy of a 3 kilogram rock falling at a speed of 2 meters per second. Okay, so this is so easy. I can just do it on the screen here. EK equals 1/2 mv squared. Right, so 1/2 times our mass, which is 3 kilograms, times 2 meters per second, and we gotta square that. Right, and you can even do this in your head. So 2 squared is 4. 4 times 3 is 12, divided by 2 is going to be 6.0 joules, and we don't have to worry about direction. Easy. Science 10 stuff. Right, and we might have to rearrange it. So find the speed of a 20 kilogram ball if it is 436 joules of kinetic energy. So again, we can use EK equals 1/2 mv squared. Move our 2 up top there. Move our mass down below, and square root it. So 2 times 436 joules divided by 20 kilograms. And don't forget to square root it, because that's where people would get it wrong. So if I type that in, 2 times 436 divided by 20, square root it, we get 6.6 meters per second. Right. Easy stuff. Okay, gravitational potential energy is easy as well. EP equals mgh, where EP is potential energy, gravitational potential energy in joules, m is mass, g is acceleration due to gravity, so 9.81, and height is the height of our object. So easy formula is found in the same spot in the formula sheet. Well, the thing about gravitational potential energy is it depends where your reference point is, right? So if I put a ball on top of this table, well, is the table my reference point? Is this where I have 0 joules? Or is this where I have 0 joules of energy? And the answer is it depends, right? The point where your potential energy is 0 all depends on where you want your reference point to be. And you're going to place your 0 potential energy point anywhere you want to make the question as easy as possible. So right now it would be probably the floor would be the reference point. But when we start doing conservation of energy questions, well, we can move it around and place it where we want. And it's pretty self-explanatory in the question. So here's an example. Find the potential energy of a 1 kilogram ball relative to the top of the table. Right. Well, the top of the table is 1.2 meters above the top of the table. So this is our 0 energy point. So we can use EP equals mgh. And it would just be 1 kilogram times 9.81 meters per second squared. And then our height is 1.2 meters. Right, so 1.2 times 9.81 times 1. Maybe I'll throw a calculator on here so you can see what I'm doing. I'm just going to open up my calculator. There we go. So 1 times 9.81 times 1.2, and we get 11.72. Okay, so the next one is asking us, well, what if we're talking about relative to the floor? So now this is our reference point. So the ball is going to be 2.2 meters above the floor. So we can just type in the same thing, but it's going to be 2.2. So it's going to have more energy if the floor is our reference point. Well, what if the center of the Earth was our reference point? Well, that's kind of a stupid question because here our gravitational field is 9.81, but as we get closer to the center of the Earth, it gets bigger. It gets bigger and bigger and bigger as we go to the center of the Earth. So we can't really say that 9.81 is going to change. So it'd be a little bit inaccurate, but we could calculate it if we assumed it was 9.81 the whole time. So all that we would do is instead of 2.2, we would have 6.37 times 10 to the 6. I guess we should add on the, oops, trying to insert that 6.37 times 10 to the 6, and we could add on the 2.2. But if we don't add on that 2.2, you'll see that we get the same answer really. So here's without the 2.2 added on, and we'd only go to 2 sig digs, so it would be 6.2, 6.2, so it doesn't actually make a difference to sig digs. So, but that wouldn't be accurate at all because that 9.81 is not accurate at all. So yeah, just changing our reference point. Okay, so this is one of the new skills that we're going to add on in this unit. So we're going to talk about units. We haven't really talked about them. We've just talked about, like, we've had newtons, meters per second, kilograms, all of that, but we haven't talked about why they are. So sometimes units are given different names in order to condense them, right? So I'm going to give an example. Magnetic field is Tesla. We don't need to know that. I'm just giving an example. But a Tesla is equal to a Newton divided by amp meter, right? So if we want to figure out what a Tesla is equal to or what a Newton is equal to, we can use the formula to help us, right? So we're going to find out, well, what makes up a joule. So I'm going to switch screens. I'm going to use my board here. So we have two formulas to find a joule. We have EK equals 1/2 mv squared. And we also have EP equals mgh. I'm just going to grab a new pen. This one's kind of dying. Toss it in the garbage can. Oh, I got it in. Perfect shot. Okay, so we want to look at units. So this has units of joules. 1/2, lots of people want to put it in there, but we're just looking at units, right? 1/2 doesn't have any units. Mass is in kilograms. and then velocity is in meters per second. And because the variable is being squared, that's also going to square our units. So this tells us that joule is equal to a kilogram meter squared per second squared. Okay, we can do the same thing with this. So EP is in joules, mass is in kilograms, G is in meters per second squared, and then height is in meters. So we can just meters times meters is meters squared. So both ways it gets us to that a joule is equal to a kilogram meter squared per second squared. Right? Use those formulas to help you. So we're going to do a board question here. So just pause the video and see if you can do it yourself. So tell me what units make up a newton. So pause the video and then I will go through it to see if you can get the answer. So if we want to take a look at a newton, we want to use a formula that has newtons in it. So we can use F equals ma, right? So force is in newtons, mass is in kilograms, acceleration is in meters per second squared. So a newton is equal to a kilogram meter per second squared. That's it. Okay. So I'm going to ask you questions on your test that ask you what these bigger condensed units are made up of. Okay. So these are the other type of questions that we're going to add on here. They're having doubling questions, tripling, whatever. So sometimes questions will be given where no numbers are explicitly given. So we can use formulas to help answer these questions. So there's two rules that we have to stick by. So if a variable is squared, we must also square the number we are multiplying. If a variable is square rooted, we must square root that number you are multiplying it by. And whatever happens to the left side must also happen to the right side. Okay, those are two rules that we are going to go by. So here's an example here. So a rocket is traveling with a certain speed in a straight line. If the mass of the rocket were tripled and its speed is halved, by which factor would the kinetic energy increase? Okay, so let's switch to our board. So to do these questions, we write out our formula. EK equals 1/2 mv squared. And we leave a little bit of space in between. So I'm just going to grab a different color from up front here. So now in front of each variable, we write down what happens to it. So a rocket is traveling with a certain speed in a straight line. If the mass of the rocket were tripled, so I focus on the three, ooh, that doesn't show up very well. Maybe I'll use blue. There we go, that shows up a little bit better. So if my mass is tripled and my speed is halved, well, what's going to happen by what factor would my kinetic energy increase by, or change by, I guess I should say. So I have two rules. One is if a variable is squared, we must also square the number we are multiplying it by. So this gets squared and this gets squared. M isn't squared or square rooted, so I don't have to worry about squaring that or anything like that. Okay, so we just want to focus on the blue stuff. So the changes on top we're making is 3 and then 1 squared. So that's going to be 3. And on the bottom we're changing it by 4. So that's what's going to happen to our left side. If that's what happens to our right side, that's what's going to happen to our left side. And our answer is, usually put like a times, so 3/4 times. Another way you can do it as well is you don't have to use fractions. You can use 0.5 if you half it. And this is 3. So if I type into my calculator, right, the changes that we're making, we just focus on the change. It's 3 times 0.5 squared, and we get 0.75. So both work and both are correct. Okay, so let's try a different example. Okay, so feel free to pause the video and see if you can do this one on your own, and then play it and I'll go through it. So I'm traveling on a boat when a rope cuts my torso in half. The captain freaks out and triples the speed. So half of me is still alive, half of my torso is alive, and then half of my torso flies off the boat. So what's my change in kinetic energy if I get cut in half and my speed triples? Okay, so I'll go through this. So again, we start off with EK equals 1/2 mv squared. Leave some spaces in between. So my mass is halving and my speed is tripling, right? And because my velocity is squared, I have to square that 3. So the blue stuff on top is 1 times 3 squared, which is 9, and the blue stuff on the bottom is 2. So my EK would change by 9/2, or 4.5 times. So that'd be my answer. Okay, that's 4.5 times. There's a decimal there. Okay, and then I think I have one more that's a little bit trickier. So by what factor would my velocity change if my mass is doubled and my kinetic energy stays the same? So pause the video, try this one, see if you can figure it out. So EK equals 1/2. Oops, mv squared. Yeah, I can not leave the spaces in between. So what we're looking for is by what factor would my velocity change. So whether I give you numbers or I don't give you numbers, if we're trying to find out about velocity, we have to isolate for velocity. So I'm going to move my 2 up, and I'm going to move my mass down below, and I'm going to square root it. So that's the first step, is isolate for the thing you're finding, whether it's numbers or no numbers. So now I'm going to write out this formula again with some spaces in between. Okay, so the question says, by what factor would my velocity change if my mass is doubled? Oops, I'm going to do that in blue. My mass is doubled, but my kinetic energy stays the same. Right, so we only want to focus with the changes in the blue, right? So I can also write this out. Instead of putting my square root over everything, what that's saying is this is square rooted, this is square rooted, and this is square rooted. So because my mass is square rooted, that was one of my rules. If I square root my mass, I also have to square root the number that I'm multiplying it by. And I want to focus only on my changes, only in the blue stuff. I don't worry about this, this, or this. Okay, so on top, I'm changing nothing. So I can put 1, and on the bottom, I'm changing by square root 2. So what's going to happen to my velocity? It's going to change by 1 over square root 2 times. Or if I see, well, what is 1 over square root 2 equal? Well, that's 0.707 times as well, if you don't want it to be in a decimal form. Okay, so both of those are correct, and that's how you do those. So here's the homework, kinetic energy stuff, really easy, halving, doubling questions, units, and then your gravitational potential energy stuff is there. So really quick, really easy, nice start to this unit. Let me know if you have any trouble. I can video chat you, I can email you, I can send you videos, whatever you need, just let me know and I can figure it out. Okay, thanks for watching.